All right, so let's try to answer this question. Why is the shortest side opposite the smallest angle in a triangle? So I have two equilateral triangles here, triangle ABC and triangle DEF. The reason I have two is I'm going to manipulate triangle DEF here. So as you can see, because all of the angles are congruent, all the sides are going to be congruent. So I ask you, what if we changed the measures of the angles? So what if I decided to change angle E from 60 degrees to 90 degrees? So I'm going to try my best here to get this to be 90 degrees. I'm kind of doing this freehand, so let's see how this works out. Okay. And then I will connect it to this side. I want it to kind of go along here. Perfect. Okay. So I have now changed this angle from 60 degrees to 90 degrees. So I'm going to draw it in right there. This is now a 90-degree angle. Now, remember, angle D is still 60 degrees. So that means because this is 90 and this is 60, this must be 30. Okay, so this is a new angle F. Okay, 30 degrees. Okay, so now, because I didn't mess with this side, as you can tell, it still has a measure of 1. Well, I have created a 30, 60, 90 triangle. So if you remember from when you learned about 30, 60, 90 triangles, and if you haven't, you'll learn this soon. The measures of the legs are going to be x and x root 3. Whoops. And the measure of the hypotenuse is 2x. Okay? So again, x is one leg, x root 3 is the other leg, and the hypotenuse is 2x. So if we look at this here, this is one leg, it's 1. Okay, so then the other leg is going to be 1 root 3, or 1 times root 3 is just simply root 3, which is approximately 1.7. Okay, and then the hypotenuse, DF over here is the hypotenuse, and that's not 1 anymore, that's going to be 2. Okay, so I've now created this new triangle, all right, that has here, and I will draw this new triangle because I always think it's good to be able to see it written out somewhere else. So I'm just going to change it. So I have the same triangle. I'm just redrawing this triangle as best I can. So this is 90, this is 30, this is 60. Okay, again, and this was F was 30. And what was it? What was 90? E. And D was 60. Okay. So if you're having trouble seeing it this way, you can look at this triangle over here. So we said that ED over here was 1. And EF over here was the square root of 3, or approximately 1.7. Okay, and the hypotenuse was 2. So look at this. Look at what happened. When I opened up this angle, the side got longer. And it has to, because if you're opening up this angle, you're going to have to draw a longer line to connect the two legs here. Okay, especially this leg staying constant. Okay, this one had to change as well. But as you can see, if we then look at the sides, we know that the longest side is opposite the largest angle. So the sides are 1, 1.7, and 2. So the shortest side is 1. It's opposite the smallest angle, 30 degrees. Okay. The second shortest side is 1.7. And if I were to change colors here so we could see it, and that's opposite the 60-degree angle, 1.7. And then the longest side, which is 2, is opposite the largest angle, which is 90 degrees. Okay? And that makes sense. And we constructed that right here. We proved that right here by making this angle larger. We changed it from 60 to 90, and looked what happened. This side had to be longer. It had to go from 1 to 2. And then this side had to be a little bit longer, going from 1 to 1.7. Okay? And I think it makes sense. So if you think about it, if you were to draw a triangle, okay, like let's say we were to have two sides here. So I'm just going to draw, okay, 1 and 2. Okay? And notice the length of, I'm going to draw this freehand actually. Notice the length of the side opposite our angle right here. Okay? It's kind of short. Okay? What if I were to open that angle up, keep the sides the same length, okay, and again I'm drawing this freehand, so I open it up a little more. Look what happens to the side. It gets bigger. Okay? It gets bigger. And then if I were to open it up a lot, and again keeping those legs the same length as before, okay? Look at that, it got even bigger. And then if I go to the extreme case of like, like 170 degrees or something, okay? And then it gets really, really long. Okay, so as you can see, as you open up that angle, the length of the side opposite it is going to get a little longer, a little longer, a little longer. Okay, and so that's how you can see intuitively that it makes sense that the longest side would be opposite the biggest angle and that the shortest side would be opposite the smallest angle.